Well, welcome to video number 3 in our CBER series on creating data sets. In this video, we're going to look at information data, formatting and organizing your data in such a way that people find it easy to understand and easy to use. We've already looked in video number 1 at the background information that we need to understand what data sets are. And then we looked at the things you need to think about before you start on creating your data set. And now in these last 3 of the 5 videos, we come to looking at actually getting down to it and putting stuff together to create a data set. So we start with information data. This is the data that I produced, that I collected, that I discovered, what we might think of as my data, the stuff that on which your publications and your understanding are based. So we need to focus here. We need to get our actual data looking like somebody could come and read it and find it useful. How do we go about that? So in the previous video, we talked about the CBER suggested format with using Excel for most things, but it's more than just the right software. It's about making your data readable. It's about making it so that when somebody opens that workbook or opens that spreadsheet, they can understand what's on it. They can read it easily. They don't have to figure things out. You've made it obvious for them what it's all about. So the key question is, when someone who's never seen this before looks at it, will they be able to see what's going on? You see, if they open it up and there's a set of figures like you have here on this slide, they're just figures. We need to work out ways of making it obvious what all these numbers mean, and in other contexts what all these words mean. So that is what we're going to try and look at in this video. So first up, number data. What do we do with our numbers to make them understandable, readable? First of all, there are tables. Most of our basic number data comes in tables, and as you look at a table of data, as you look at your spreadsheet, clarity is the key here. Use colors to make it clear whether this is a heading or whether this is normal data, whether this is a calculated piece of data or one of your fundamental readings. Use colors, very light colors with very dark text, or very dark colors with very light text. Always make the contrast between the fill and the text very, very stark. And yeah, and just about colors, don't use very bright colors. Use more muted colors. Those bright yellows and reds really make it hard to read a table. It's much better to use the darker, more subdued colors or the light colors rather than the very bright ones. Then use some borders. Use thick borders for major divisions and thin ones for minor divisions, but for most of your, leave most of your table with no divisions. But use the divisions to make it clear. For example, use a division to show that 3 or 4 readings of different sorts are all on the same day, or that 3 or 4 readings are all the same type of reading, and the next lot are a different type of reading. Maybe PH is all in one block, and and EHs all in another. And then often we have tables where we have calculations. So make sure that you put in somewhere a block with the formula that you've used, so that somebody doesn't have to go backwards to the formula to work out what it is. Use very good descriptive headings and so on, so that it's clear what's been calculated from what. But in a single table, on a single spreadsheet, don't do calculations that are too complex, that are too involved. Rather put those on a separate spreadsheet. And then remember, when someone opens a spreadsheet, they open it with, and everything that they see is top left. And if the table goes on for too long, or if the spreadsheet has a lot of stuff on it, the stuff on the right and at the bottom is invisible. So if you are putting things, if you're calculating totals or averages or so on that use the rest of your table, the rest of the numbers on your table to do the calculations, put them on the left, put them on the top, not on the right, not on the bottom, because if somebody opens up the table, they will not know that there's a calculation giving you an average at the end or at the bottom. And then make sure that none of your calculations depend on another workbook. Put all the information that is needed in a workbook into that workbook, even if you have to repeat it in several workbooks, because someone may download only one workbook, and then the workbook, the Excel workbook, will be trying to fish information out of a non-existent second workbook. So always make sure that all the information needed for calculations is in that workbook where the calculation happens. Graphs and charts. These are another form of number information, obviously. If you're doing simple graphs and charts, you can put them on the left next to your table. Do put them on the left and not on the right, because nobody will know that they're there if they're on the right and sort of vanished. But only do simple graphs and charts on the same spreadsheet as your numbers, as your numerical table. If you're going to do multiple graphs or charts, if you're going to do big complex things, rather put them onto a separate spreadsheet and get the information back from the spreadsheet with the numbers on it. And then just a few little things about graphs. There's some slightly different things that you have to notice for the graphs in a spreadsheet. You must give the graph a title. In your publication, you don't give the graph a title because the title is in the caption. But in your workbook, you don't have a caption. So the caption, in effect, is the title. And then make sure you label your axes and choose sensible intervals. And of course, you must have a legend. You must make this graph stand alone, if you like, without the table. People mustn't have to guess what's in it. So that was numerical data. Now what about images? Quite a few of our sets of data come from images, whether it's images in a microscope, from a microscope, whether it's chem scan images or whatever. We do use images quite a lot. So first up, seminal images. If in your work you've produced an image, especially spread, a an image showing different different reactions, or an image of your rig, or an image of a flow sheet. If you've produced an image that you are going to want to use in many publications, basically it's if you've got something that's a basic that you're going to need to use again and again, don't first publish it in a closed publication like a journal article. Publish it as a standalone item in Ziva Hub, just that one image, and it'll have its own DOI, and it'll be open source, and you can use it as many times as you like, referencing that DOI, and of course yourselves as the authors. This is very important, because when we publish images first in reports or journal articles, we end up using them multiple times and finding it difficult to make sure that we always reference them correctly. And images are difficult because you often have to get permission to reuse them. So if you've got an image that you think you might want to use again and again, put it up as a standalone Ziva Hub item. And you must do this before you publish any kind of publication, journal, report, etc., with that image in it. And then you reference your Ziva Hub item in all your publications. Secondly, photographs. Remember your scale bars. Select and shape the photograph. And then create a shape behind the photograph, which and then group the photograph and the shape, and put all the information about the photograph in the shape. That way the photograph and the shape don't get separated from each other, and all the information about the photograph is present and correct. Just notice that there's a considerable amount of information which you should record when you take a photograph, and which should be linked to the photograph in your data set. We'll look in the next video at some of the background information you need, but you need to put proper information in your with your photograph in your data set. And then choose your file format carefully. The two most common are TIFF and JPEG, and TIFF files don't have lossiness, so they don't lose anything, but they're very big. They take up a lot of data, a lot of space. So only use that for photographs that have got key information, such as microscope photographs sometimes, and some of the other sort of photographs that reveal things about the stuff we're working with. Otherwise, usually JPEG is good. Then flow sheets. So from PowerPoint, you can just put your flow sheet in. You select everything on the PowerPoint slide, you group it, you copy it, and you paste it, not as an image, and it retains all its PowerPoint functionality. Somebody would be able to download your file, copy that image, and place it into a PowerPoint and manipulate it as they choose. And if you want it to look good on your view, uncheck your grid lines so that it comes out with a white background. from other software, you would usually have to paste it in as an image, and then it loses its functionality. But you can always put a supplementary file with the other with the image in its original format, but just make sure that you state what the software is, so that if people want to open it functionally, they know what software to look for. When you make your flow sheets, try and be really clear about them. Think about them carefully. Put things in lines, line them up, or use colors again. Use designations like A, B, C, 1, 2, 3. And when you have designated flows, often you'll put a spreadsheet, a table, alongside your flow sheet with more information about the streams and so on. And then other sorts of diagrams. Obviously, we've looked at photos already, but often you would have a photo of your rig. And when you have photos of things like rigs, always annotate them. And always include dimensions and scale bars and the materials you use, that sort of thing. Give people all the information they need. And then the same as with the photographs, diagrams can be pasted in with on top of a can't think of what they're called now. a block, and you group the block and the diagram, and you can give all the information you want to give about the diagram. So that was looking at images, and now obviously we also have data that comes as text. Firstly, tables. A lot of the same ideas apply to text tables as I talked about in numerical tables. Just a couple of key things. Include columns which make it possible to sort your data. So, for example, instead of putting the year of publication in with the authors and title, you put the year in a separate column, and then you can sort it by year. In this table that we see here, things have been categorized, and on the left there's a table which is a key to the designators for sorting the different columns, well, for sorting that column. So be savvy about your the information, and when you put it in a separate column and when you keep it all in one column, and make sure you give people enough information. Yeah, sometimes to divide into categories, you can use numbers, you can use letters, you can use a combination, you can even use phrases, which make it easy to sort your information. And again, use your colors, use your borders, use them wisely to make it easy to read. Then quite often we will use decision matrices. If you get complicated with your decision making and use game theory and so on, I don't know, that's beyond me. Then you have to find out from someone else. But basically, when you make decision matrices, many of the same ideas apply as in a normal table of text. Important thing is to show how the matrix works, and to give it a good key. a good legend, and then use colors well so that it helps to read the matrix. Questionnaires. Now, questionnaires are important. It's no good showing the answers to questionnaires without showing the actual questionnaire that you used. So paste the actual questionnaire in. You can paste it in as a Word document into a spreadsheet, and it just comes up like an excerpt from a Word document. If you've got what are known as thin research questions, in other words, answers are yes or no, or numerical, or single word or phrase, you can tabulate your results. They're text results, but you can tabulate them. If your research questions are thick research, where the answers are much fuller, whole paragraphs, the person is thinking, you need to retain all your audio, video, and transcripts, and they're all referenced in a separate item called a metadata only item, where you put in all the information about your files, but you don't make your files available. But people who want to know what's in the files can apply to you for permission to look at them, and maybe given it or not given it depending on why they want to see it. Now, modeling data. This is a little more complex for me. First up, define your arguments. So in your model, in your code, you must make sure that your arguments have got good definitions. Otherwise, people don't know what needs to go in there or what has gone in there. So clearly define them and make sure that you specify the units for your own sake, because if units are inconsistent, the model goes wrong, but also for the person who's going to be using it, because they need to know what input is required and what the units of that input must be. So make sure you give the information in your code. Secondly, download and run. You must upload your simulation, your model, in the format in which somebody can download and run it. And that means you must tell them what software it's in, whether it's MATLAB or SuperPro Designer or Aspen or whatever, and or if it's straight code, what your programming language is. And of course, we do also make some models in the simpler form of Excel. So whatever software you've used, you must upload your model in a form that can be downloaded and run. So that's a little bit about the information data, how you go about putting it out there, setting it up so that people can understand it and use it. And in the next video, we'll be looking at explanation data, the extra data that you need to put in to make your actual data usable. Just a quick acknowledgement, as I always do, to UCT eResearch and the Digital Library Services for their help in training me up, and actually from multiple small courses that I've done over the years in terms of getting my act together here. And when you come to me with questions that I can't answer, I go and ask the eResearch people or the Digital Library Services people.